our product development engineer, and we're going to give you an overview today in regard to the space gas utilisation of space gas with Treadwell's structural members and sections. So Locke Ho is a structural engineer, and he's been with us now for a good while, and he's developed a lot of good online tools, and the space gas input data is just one example of the smarts that Locke has made available to consultants. I'm just going to introduce the company to start with. So Treadwell is a specialist in composite FRP or fiberglass reinforced plastic products, and our range covers a number of different brands. We have our access systems range, which is predominantly access related products, so products that utilize FRP grating and handrailing and ladders predominantly, but more than that, they typically incorporate complete access structures, platforms on various plant infrastructure and the like. And they commonly utilize the Architects range, which is our range of FRP, again, composite fiberglass reinforced plastic, structural beams and channels and so on. So that range is quite substantial, and we do have a product guide that is dedicated to that complete range. Then we have the EnviroTread range of products, which is all of the recreational public infrastructure related products, so boardwalks, jetties, and similar products, shelters, etc., for the public space. Further to that, we have the range of water and wastewater treatment products, and those products are typically odor control covers, baffle walls, and other such products for the water and wastewater treatment industry. So we deal with many of the water and wastewater, I should say the water authorities nationally, and well, nationally here in Australia and in New Zealand as well. Further to that, we have the range of cable ladder and cable tray and instrumentation products that come under the X-Duro banner. Again, completely composite FRP, non-conductive, non-corrosive, and obviously rust and rot proof like the rest of our range. Then we have the Safe Series anti-slip products. So these are all typically retrofit anti-skid or non-slip profiles, including the likes of sternosings, ladder uncovers and caps, and deck plating products. And then we have a full range of composite or FRP fencing products as well. So everything from palisade style fencing through to screening, and again, completely of FRP or composite construction. So I'll now hand over to Locke, who will go through for us the actual presentation on the space gas range. But before I do, I'll just quickly show this slide to you, which is typical projects that we get involved in. So you'll see here there's composite FRP bridges, staircases, shelters, which all come under the EnviroTread banner. There's also an industrial project up in the top left corner here, which is an industrial access structure, and incorporates the full range of Architects FRP columns and beams that create the primary structure. And then there's the Rail-X round FRP handrailing, and that follows right down onto the step type ladder as well. So over to you, Locke.
Yep.
Look forward to hearing what you can show us on the space gas front.
Yep. Thank you, great. Hi everyone, I'm Locke. Welcome to our space gas webinar. I am the product development engineer and also part of the structural engineering team at Treadwell Group. So here are some speak gas model examples. So the modeling method will be the same as modeling timber structures or steel structures. However, in the market, there's no structural analysis software help us to choose the correct size of FRP member. Therefore, actually, speak gas could only help us to determine the deflection and the required design node like shear, bending moment, and tension and compressions. So we can base on those design value and compare with the standard. So Treadwell Group provide the speak gas member library so that the user no need to spend extra time to draw the layout of the sessions. Now I will show how to download our profiles. First, go to our homepage and go to Resources Center. Roll down and you will find a download button, and then you can click download. After that, you can copy the SLM file and the SLS file to the Treadwell library, to the speak gas library. And then this include the FRP material properties and also the Treadwell profile. As you can see, you can download the I-beam sessions, C session, equal angle, and square hole session, etc. So when you select the profiles, it will show the geometry of the session, like the moment of initiation, the height, the width, the thickness. For the yarn models of FRP, as you can see in the screen, we are using 19.6 GPa. So actually, it's already considered some reduction factor based on the ACMA pre-standard, which considering the resin type, temperature, moisture, and if you need to consider the long-term diffraction, like a longer design life or a higher temperatures, or there's some extra chemicals, maybe you need to further reduce the yarn modulus. Next, I will demonstrate an example. So the joint spacing will be within 3 meters. The width will be roughly 2.4 meters. The height of the columns will be 0.7 meters to 1.5 meters. The live load will be 4 kPa. The window region is A1. So as you can see in this example, we use different kind of our Treadwell profile. Let's say the post, we are using a square hollow section, 102 times 8 mm thick. For the outer joints, we can choose C sections, 152 high times 9.5 mm thickness. For the inner joints, we can use the wide French beam, 152 times 9.5. For the barrels, normally we will use double C channels, like 203 times 9.5. For the post bracing, we can use the equal angle, 102 times 9.5. So when we do the speak gas model, normally we will assume the joints as pin connections because FRP we can't fail them. So now we talk about the procedure for the design check. So as I mentioned in the beginning, we can use speak gas to do the checking for the deflections. Like in this example, for the inner joints, wide French beam, the deflection is roughly 8.9 millimeter, which is smaller than the span over 250 or span over 300. So it passed the SLS. So the reason that I'm first checking the deflection is unlike steel, FRP don't have that higher yarn modulus. So based on our experience, most likely deflection will govern the design first. So after we do the deflection checking, we can do the ULS checking, the ultimate limit state design check. So based on the speak gas model, we can know that the required bending moment is roughly 2.5 kNm. And actually, we can refer to the ACMA, the pre-standard. in 2010. The reason we are choosing the ACMA standard is because it is the newest standard in the FRP market. And as I know, at the end of this year, ACMA will also have a new real standard, not a pre-standard, end of this year. So actually, I think ACMA is a good standard to reference because they spend a lot of resources doing the testing. So back to our design. So for the capacity member checking, in ACMA, we can check the material rupture due to bending. As you can see, is 10.5 kNm. In the standard, we can also check the local flange or web local buckling. This is 22 kNm. Lastly, they also show the equation that how to calculate the lateral torsional buckling. So as you can see, if we don't put any bracing, it is 3 meter unbraced length. The member capacity can only be 1.5 kNm. So if we add one extra lateral bracing, the torsional bracing, it will become 4.1 kNm. So it passes the bending moment. Next, based on the model, we can also read the shear force in space gas. So we refer back to the standard. For the shear force, we can check the material rupture due to shear. Second, we can check the local web shear buckling. So there's an important note that the value is based on the assumption we input. Let's say the resin type, the temperature, moisture, time effect factor. Of course, in FRP, higher temperature, we need to put more reduction factor. Third, I will talk about the connection check. So again, we'll refer to the ACMA standard. So based on the standard, it shows the layout of the connections, the layout of the connections. As you can see in the pictures, it mentioned the E1, the end distance, which is 4D or 2D. So D is the diameter of the bolt, let's say M12 or M14. It also shows E2, the edge distance 1.5D. So in FRP connection design, normally the most common failure mode, first is pin bearing, second, leg tension failure, third will be shear out. Now I will show typical connections for 152 height member connections. So refer back to our space gas model. We are using a 152 internal joist. So when we do the FRP connection design, we need to check the primary beams, secondary beams, and the bracket. The reason I need to check is because in FRP connection, each component thickness is important, and also the direction of the fiber is also important. So we need to know that whether we are designing the member based on longitudinal direction or transverse directions. So in this table, it's showing that I've checked the connections based on the pin bearing, leg tension strength, and the shear strength. As you can see, for the single leg connection, single leg, which means we only put one equal leg angle on one side, the strength is only 3.28, which is smaller than the required shear 3.48. So that's why we need to use double leg shear, which means we need to put 2 equal leg FRP brackets on each side, and it becomes 5.47, which is larger than required shear. So just note that again, we need to have a pretty clear assumption of all the resin temperature, time effect factor. So lastly, we will check the post and bracing First of all, we can check the compression and tension also based on the ACMA standard. In tension, we can check the tension rupture. In compression, we can check compression rupture. Second, compression global buckling. Third is compression local buckling. For this, however, I think connection is still the most important thing in the structure, in the post and bracing. The reason I'm saying that is you can use, you will find that you can use a really thin profile that can pass the tension or compression. But sometimes you will find that because of the chosen thickness is not thick enough, the connection will fail based on maybe pin bearing or shear out on the bracing. So this is the end of my today presentation about space gas. So our upcoming webinar will be the debugging FRP maps. So thank you for your time. Now will be now is a Q&A sessions. Please feel free to use the Q&A function in the webinar. Thank you. Thank you.
Thank you very much, Locke. Brilliant presentation there. We're looking forward to the next webinar when we will go over the debunking of myths around FRP. Looking forward to delivering that to our clients. Keen also to answer any questions should they arise. Don't have any right at the moment, which is brilliant. Feel free to email us though, of course. Locke's details are here on the screen. So it's locke.ho@treadwellgroup.com.au, and Locke is also on LinkedIn, like most of the staff here at Treadwell are. We look forward to hearing from you, and remember that our space gas input data is also available on the website, and further to that, it is actually part of the library as well. Looks like we do have some questions coming in, so we will take a few of those and answer them now. Still got a little bit of time left, so we'll quickly answer as many as we can and then move on. I'll leave it with you for another minute or so, Locke.
Yeah. So okay. I received a question about whether our online tools can pass the engineering certificate. So so first of all, for our online tools, we are using the factor of safety approach. So in the online tools, we use our factor of safety equals to 3. So actually, this is more conservative comparing to the standard, because if you, let's say you're including the reduction factor of the member, also some reduction factor of the chemical environment, temperatures, or time effect factor, actually it is less than the factor of safety equal to 3. But it also depends on the actual environment. If the temperature is really high, if the time effect factor is very high, then maybe sometimes factor of safety equals to 3 is not enough. But I would say our online tools, in most of the case, is more conservative than usual. Hope I can answer your questions.
Thank you, Locke. Brilliant. We appreciate everyone's time, and we look forward to seeing you on the next webinar. Should you have any further queries, questions, or should we be able to help you further at all between now and then, we're only a phone call away. You're welcome to email us anytime, and we look forward to serving you. Thank you all.
Thank you, everyone.
Goodbye.
Goodbye.